title is just force. I want to write that down, please. Did I start the recording? I did. Yeah? Okay. Right. So we all understand the word force. You know it from English, you know, to push or pull, something like that. But what exactly is force in physics? So, not this. If you've seen this movie. Okay. Right, so what exactly is force in physics? So force is what changes the motion of an object. That is, force will either change the direction, the speed, or sometimes both. In other words, force causes an object to accelerate. So this is the key part of the definition that you would need for the exam. Oops, sorry. Oh my goodness. I suppose actually for the exam, if you had this, it would be enough. Okay, you got that?
Yeah.
Yep. That's the key part.
Does it deaccelerate?
Yeah, or decelerate. We use accelerate to mean both decelerate and accelerate. So like, if it decelerates, we still can call that accelerate, just with a minus. Yeah. Right. Does a force always change the speed or direction? Well, forces can do other things as well. Forces can have other effects, such as changing the temperature or the shape of an object. But actually, you don't need to write that part down. But actually, we'll discover later in the course that this is also a type of acceleration, but that's for later. It is true to say that if an object is accelerating, then a force is being applied. So if an object is accelerating, then there's definitely a force that's causing this. Okay? So if you have an acceleration, you have a force. And also force is a vector, because acceleration is a vector. So force obviously has a direction. You know, you can push this way or you can push this way. And of course it has a magnitude, or you can pull. And it has a magnitude. It can be a big force or a smaller force. It's definitely a vector. So how do we measure force? Well, the unit we use is called the Newton. Yeah. And the definition, the letter for Newton is N. And the Newton of force, the definition is the amount of force required to accelerate 1 kilogram by 1 meter per second squared. And this definition is actually pretty common in the exam. Yeah. So if I just kind of draw this to give you the idea. Where's my pad? There we go. So if we have, oh come on. Come on. There. Okay, sorry. Right. If we have 1 kilogram and it's accelerating with 1 meter per second squared, then that means there's a force of 1 Newton being applied. Okay. Common definition question for the exam. Right, next now. So learn it off perfectly. Okay. So the relationship between force and acceleration is given by Newton's second law. Newton has 3 laws, which we'll look at. The second law is what we're going to look at right now. So Newton's second law tells us that now this is just one way to put it. The force equals
measure and the A is
I'll tell you. Force equals mass multiplied by acceleration. Yeah. So if you know the m and you know the a, you can know what the f is, or other ways around as well. Where force f is the force being applied, m is the mass, and a is the acceleration. In fact, Newton's law, you can say it other ways as well, but for right now, F equals ma is what we're going to use for it. So, write that Newton's second law, F equals ma. If you can write that down, please. What unit is force in here, in this equation? What's the unit for F? Newton. What's the unit for MA?
kilogram meter per second square.
So in fact, 1 Newton is the same unit as 1 kilogram meter per second squared.
It's written in short to
Newton, yeah. So I mean, if you saw a kilogram meter per second squared, it's also a Newton. Yeah. Okay, that's good. That's good. For now, we'll use this form. Now note that there's another way to state this formula, and that has its own lesson, which we'll look at later. And also the units are the same. I said here that the Newton is the same as a kilogram meter per second squared. Okay, so here's our first question, and in fact I think the formula is so easy I can let you try it. A 45 kilogram girl starts to run from rest with acceleration of 2. What force is she applying in order to accelerate? So, if you can just calculate that, please.
90.
Yeah, 45 times 2. So, there's 90 newtons of force. So, what that means exactly... So, if she starts to run, in her legs, the force is 90 newtons. And that's equal to, it was 45 multiplied by 2, as an example. Okay. What's the name of the person who makes your coffee?
coffee man.
Coffee man. I like it. No. But I like it.
Coffee man.
Coffee man. Give me a coffee, please. No, not coffee man.
Waiter.
Not waiter. Now, I said they make your coffee, not bring your coffee.
Barista.
That's it, yeah. I was expecting you to know that because in Korean it's the same word as in English. So in Korean and in English it's the same word. Barista is the person who makes your coffee. So I had a Korean student last year and she was the only one who knew it. And she told me it's because in Korean it's barista. I take it then in Arabic it's not this. It's some other word.
Yeah.
Do you even have a special word for the person who makes the coffee?
Yeah. I mean, coffee in Arabic is qahwa.
Yeah.
So it's qahwaji.
So this is like coffee maker, is it? Or something? Yeah. Okay.
Exactly.
So it's the same idea, barista. It's good to know this. Increase your vocabulary. So you'll see a barista slide a cup of coffee along the table. So he has the cup of coffee and he slides it over to you. The coffee is initially at rest, and then it leaves his hand at 30 centimeters per second, and it looks like he's touching the cup for 1 second, and you think the coffee is about 500 grams. So I'll draw this for you. What you have your cup of coffee, and the mass is 500 grams, and he pushes it, and it's at the beginning it's 0 meters per second, and then afterwards, after he pushes it, it's moving then at, I said 30 centimeters per second. And how long is he pushing it for? The time here, I said it's 1 second. So, I want you to calculate the force in his hand. Okay? There's the story again. You can draw it or you can write the information down or whatever. But what's happening here is he has something like this and he pushes it for 1 second. And for that 1 second, he's given it a force. Because for that 1 second, what's happening to it? It's accelerating.
So we have to convert it in.
Well, the very first thing is to get meters per second.
Can you show us the drawing, please?
My beautiful picture?
Yes.
Yes, okay. But I would kind of prefer you to read it and to draw it as well, because in the exam they won't give you pictures, you know, so you need to be able to read it and draw this, okay? So I'll give you a minute to try it, a minute or two, okay? See what you can come up with. But you're right, the first thing is to convert the centimeters to meters. Now that's actually pretty easy to do, because centi is 100, 0.01. So
0.3 and 0.5.
yeah. Yeah, that's it.
0.3.
Yeah.
In the exam, should I just write 0.3?
Oh, what? Always write your units. Remember that story I told you?
No, I'm
No.
talking about like converting.
Let me just put it this way. When you can use units, do use units.
No, I will, but like 3 centimeters. 0.3 meters.
Oh, you mean just directly?
Yeah.
Yeah, that's fine, yeah. Because for something like this, it's clear.
It doesn't have to do the equation.
Yeah.
0.15. 0.15.
The force, is it? We'll have a look now, yeah.
Yep.
Yeah, okay, good job. Well, I don't know if it's right. Let's calculate it. So, okay, the first thing is quite trivial. We make this 0.3 meters per second, and we should make this 0.5 kilograms. Now, we know that F equals ma. Do we know the m? We sure do. Do we know the a?
Yeah.
Well, we can know it, yeah.
The speed we need to.
Yeah, we can work it out.
Yes, we will divide it by 1.
Yeah,
so
yeah.
Obviously, it will be.
UVATS 0, 0.3, 1. So we'll use V equals U plus AT.
Yeah.
Can you see that, Andy?
Yeah.
So what's the A?
0.3.
Over 1, yeah.
Yeah, so
the
this.
formula of acceleration.
Same.
Oh, that too, yeah. So 0.5 multiply 0.3, so then it's 0.15 newtons. Okay, that's okay, yeah, you got that, good job. Continue? Yes, can you just move the projector a little to the left? It's getting a bit put off there. Yeah, okay. Do you think we need to focus it, the lens a little bit? It's a bit blurry. Oh, yeah. Oh, yeah. Now we're talking. Okay, continue?
Yeah.
Yep. Right. Okay, here's another one. A 1,200 kilogram car is traveling at 100 kilometers per hour on the motorway. The driver suddenly brakes and the car screeches to a halt over 100 meters. There should be a space there. How much force are the brakes applying? So when the car is traveling along the motorway and it suddenly stops, it is decelerating or accelerating with a minus acceleration. And what is causing this are the brakes. So the brakes are applying a force to decelerate the car. So it's the brakes that are doing the force here, the force job. So again, it's a lot like the last one, except it's a little trickier because you have to convert 100 kilometers an hour into meters per second. Yeah, but see what you can get here for the per second. That's one fast car.
Well, but that is 600.
Yeah, this is
27.7.
yeah. Don't forget your 3,600 seconds in an hour.
Yeah, it's
Yep.
27.77.
27.7. Okay, good. Try to do this one now. Or are you saying that's the final answer? No, that's too small. That's the 100 kilometers.
Yeah, it's converted.
Okay, try to get the force here, please. And technically the force should be negative because it's acting backwards.
I think it's 332.3.
Don't know, haven't done it yet. That sounds believable, but I would have thought it would be bigger. I don't know, my instinct would have been that it should be in the thousands, but
Maybe, but I've divided it by 100 if we go like, 1200. $3,000, 33,000
this sounds more like what it could be, yeah.
minus.
Let me write down the information. So, here is our car-ish. Right, so the U is, 100 kilometers an hour, and you converted it into, what was it, 27.78 meters per second. The V we definitely know, it's 0, comes the rest. The A we need, the T we don't know, the S we do know. So the force and the acceleration is acting backwards, and there, look, there's my driver there. The car's going this way. So what formula could I use to get the A here? B squared? B squared, I think. B squared equals U squared plus 2AS, so that's 200A. Yeah.
Like how you got 27.7?
That was, I didn't write it down. It was 100 kilometers per hour. So that's 100,000 meters per hour. But hour is 3,600 seconds. So what's that? 27.78 meters per second. Yeah. Right, 27.78 squared divided by 100? No, 200, wasn't it? Okay, I'll go back here. So the A is minus 3.86 meters per second squared. So using Newton's second law, F equals ma. What's the m here? It's 1200?
1200.
So you get minus 4,630 newtons. Or, if you want, you could say that's minus 4.63 kilo newtons, if you like. Got that? Yeah. Can you see that really? It's kind of just continuing what we were doing last week with the motion, except we just have one extra formula now, F equals ma. Yeah. Okay. Iyad, do you have this? Or? Yeah? Okay. Mutada? Mahmoud, not Mutada. Mahmoud. Right. The force is negative because the car is decelerating. Yeah? Going back, yeah. Okay. Now it looks worse than it is because there's not that long to do, alright? So maybe I'll let you do. Yeah, I think you can do. Well, let me actually see what the next lesson is. If it's a big one or a small one. Lesson.
Wait.
I don't remember how big this one is. Let me just have a quick check. I don't think it's too bad. Let's have a look. Oh no, it's pretty big. Okay, so maybe we'll just get a start on the next one then. If you want to take a snap of that, that's fine, but it's on Moodle as well. Okay. Right, I'll stop